Welcome to a slow, beginner-friendly lesson on configuration and secrets in Python, made for absolute beginners. Stay safe. Today you learn one of the most important habits in professional Python: never put a secret directly in your code. A secret is any value that gives access to something valuable: an API key, a database password, a token from a cloud provider. If a secret leaks, someone can pretend to be you, spend your money, or read your data. The good news is that the safe pattern is simple. You put secrets in a separate file, you read them at runtime, and you keep that file out of Git. We see the whole pattern today. Secrets stay outside. Your project has this shape. A folder called secret_app holds everything. The .env file lives at the root, and so does .gitignore. The real Python code lives under src/secret_app, in files like config.py and main.py. Notice the .env file is at the project root, next to pyproject.toml. That is the conventional place for it. Notice the .env file. Create the project with UV space in it. Add two libraries, requests for calling an API, and python-.tn for loading the .env file. Both are common in real Python projects. Then add pytest as a dev dependency so you can write tests later. UV records everything in pyproject.toml, so anyone who clones your project can reproduce the exact same setup. Two libraries today. First, create the .env file at the project root and put your secret inside. Then edit main.py to read that file at runtime. Run with UV space run space python space -m space secret_app.main. If the secret is missing, your code should fail with a clear message, not a confusing traceback. We write exactly that pattern today. Read at runtime only. A secret is like a key to your house. You would not tape it to the front door. Treat secrets like keys. Why do we care so much about secrets? Because a leaked API key can run up thousands of euros of cloud bills overnight. A leaked database password can expose every user record you store. A leaked cloud token can let attackers spin up machines in your name. The leak itself takes seconds, you push to Git with the key still in the file. The cleanup takes weeks. Prevention is far easier than recovery. A leak is expensive. Here is the bad pattern. You write the secret directly in your code, as a string assigned to a variable. It looks harmless. But every person who reads the file sees the secret. Every copy of the file carries it. Every Git commit stores it forever, even after you delete the line. Anyone with access to your Git history can dig it up years later. This single pattern causes most of the secret leaks you read about in the news. Never do this. Why is hard coding so dangerous? Because Git never forgets. Once you commit a secret, every clone, every fork, every backup carries it. Even if you delete the line in the next commit, the old commit still has it. Anyone with read access to the history can find it. Sharing a file by accident, posting code in a chat, opening a pull request, any of these can leak the secret. The only safe habit is to never let the secret enter Git in the first place. Git never forgets. The safe pattern starts with a .env file. This is a plain text file at the root of your project. Inside, you write key equals value lines, one per row. The key is a name you choose, like API_key. The value is the actual secret. The .env file is plain text, so it is easy to read and edit. But it never goes into Git. We see how in a moment. Outside the code, your code reaches for the secret only when it runs, never before. Flows in at runtime. The .gitignore file tells Git which files to skip. You list the .env file by name. You also add patterns like .env.star to catch variations. You can add other sensitive patterns too, .pem files, .key files, anything that should never be committed. When you run git status, Git will not even show these files as untracked. They are invisible to Git, which is exactly what you want for secrets. Hide it from Git. At runtime, your code reads the secret from the environment. The os module gives you os.environ, a dictionary of every environment variable. Call os.environ.get with the key name. It returns the value if the variable exists, or none if it does not. Always check for none. If the secret is missing, raise a clear error so you find out immediately, not 3 layers deep in a confusing traceback. Read the environment. Reading the .env file by hand is tedious, so a library does it for you. Import load_.tn from the python-.tn package. Call load_.tn with no arguments. It finds the .env file at your project root, reads every line, and puts each key value pair into os.environ. After that, you read os.environ as if the values had always been there. One function call, and every secret is available. One call loads everything. Walk the journey of a secret. The secret starts in the .env file on your disk. At runtime, your code calls load_.tenv, which reads that file and places each value into the environment. Your code then reads the environment and uses the value. The .env file itself never enters Git, because .gitignore hides it. The secret flows from file to environment to code, but never into version control. That is the whole safety pattern in one sentence. File to environment to code. Here is the secret in action. Load the environment, then read the API key. If the key is missing, raise a clear error. Otherwise, build an authorization header with the key and call the API. Notice the key is never written as a literal in the code. It always comes from the environment. Anyone reading the source cannot see the secret. Anyone running the code with the right .env file gets the right behavior. A real request. When secrets live outside the code, your code can be shared, read, and trusted. Code you can share. Real projects run in multiple environments. Development uses a local database and test keys. Staging is a near copy of production, with its own keys. Production uses the real keys and real data. The code is identical across all three. Only the .env file changes. This is the power of the pattern: one codebase, many environments, each with its own configuration. The secret never lives in the code, so the same code can run anywhere. Same code, many places. The .env file is not only for secrets. It can hold any configuration value that might change between environments. The log level. A timeout in seconds. A feature flag that toggles new behavior on or off. Anything that is not code logic belongs in configuration, and the .env file is a simple place to put it. Your code reads these values the same way it reads secrets, with os.environ.get. Not only secrets, build these habits from day one. Never type a secret as a string literal in your code. Always list .env in .gitignore before you create the file. Provide a .env.example file with fake values, so teammates know which keys to fill in. And always check that a secret exists before you use it, with a clear error if it is missing. These 4 habits prevent almost every secret leak you will ever read about. 4 safe habits. Hold the takeaway. Secrets never belong in your source code. Put them in a .env file at the project root. Use python-.env to load that file into os.environ at runtime. And add .env to .gitignore so the file never enters version control. The code you write stays clean, shareable, and safe. The secret travels with the environment, not with the codebase. Outside, never inside. If you want a quick practice, do the full pattern by hand. Create a .env file with one fake key. Add .env to .gitignore with the echo command. Then write 3 lines of Python, import load_.env, call it, and print the value of os.environ.getAPI_key. If you see the fake key printed, the pattern works. If git status does not show .env, you have kept the secret out of version control. Try the full pattern. Next lesson changes topic. You learn continuous integration and continuous deployment, often abbreviated CI and CD. You see how GitHub Actions runs your tests automatically every time you push code. Green tests mean the code is ready. Red tests mean stop and fix. This is the workflow every professional team uses, and it is the natural next step after writing tests. Continuous integration next. Thanks for learning how to handle secrets safely. Next we meet continuous integration and continuous deployment. See you in the next lesson.